Hello guys, welcome back. Today we're going to be going over that bit circuit that I talked briefly about in the last video. I'm going to try to go over some of the logic, though honestly this is one of the harder circuits to understand, but this is basically what makes up a computer in a very large part because this circuit has the ability of memory, meaning that it will remember its output so that you can use it to save information. So right away we see that it's built of 4 NAND gates. Now let's go ahead and remember that NAND gates, if any one of their inputs is off, its output will be on. And this circuit seems relatively simple except for this one little piece right here where we have a feedback loop. This is a little bit weird, but we'll see how it comes into play later. So let me go ahead and jump in. So right away when I start the circuit, we see that it takes on basically what we would expect. Both of our inputs are off, so our output for this bottom left NAND gate is on. This NAND gate still has one input that's off, so it's on. And then this little feedback loop ends up evaluating to where our top right is on and our top left is off. And this right here is our output, and these are 2 inputs. This bottom left input is normally considered the actual input, and the bottom right is normally called the setter. And we will see why it's called the setter here in a second. So I'm going to go ahead and possess an actor so that I can actually control some of what's going on here. So up in the top left, we see just some of the controls that I set up for myself. So the G key will control the input, if you can see me toggling that right now. And the B key will control the setter, if you can see that. So now let me go ahead. Let's see what happens when I turn on the input. Well, nothing happens. When we look at it, why does nothing happen? Well, our bottom left NAND gate still has one input that's off, so its output has not changed. It's going to stay on. Let me go ahead and turn that off. Let's turn the setter on. Once again, we see nothing has changed really as we expected because our NAND gate in the bottom left is still on. The NAND gate on the right, the bottom right, is now off, but the top right NAND gate is still on because it only needs one or more inputs to be on. So let's go ahead and turn that off. So now let's try turning both of them on. And now we see that something has happened. Our NAND gate is now off and our output is now on. And so we've now turned on our output. This is where things get a little bit trickier with the feedback loop. So we see how the feedback loop has now switched position where it's now the top left that's on and the top right that has an off output. So I'm just going to go over the functionality a little bit here. I hope you can understand the logic behind it. So I'm going to turn the input off now, and we see that it's reverted back to the state that we would expect it to be in. Once again, our bottom left NAND gate is on because one of its inputs is off. So now let's try something a little different. Let's turn the setter off now. Well, this is a little strange because our output for the circuit is still on. And this all has to do with how this feedback loop works. So when we turn the setter on, we see that this right NAND gate does not change. And that's kind of the key to this, is that with the feedback loop, we can keep that top right NAND gate off. And now what's even better is when I toggle the input, we see that the output doesn't actually change. And so now, for instance, if I turn the setter back on, we see that the output is now off because our input is on. And so hopefully what you're realizing here, so let me go ahead and turn the set back off, and then we see that no matter what I toggle the input to, it's still off. So I hope what you're realizing here is that the output will stay at whatever the input was the instant that I turned off the setter. So like I did before, if I have the setter on and the input on, when I turn the setter off, the circuit has now remembered that it was on. So no matter what the input is, it's always going to be an on output. And likewise, if I turn off the input, turn off the setter, it doesn't change once I start toggling this input. And so this is how memory inside a computer works. And I should specify that this is specifically RAM memory or a register. This is not how a hard drive would function. And so, but basically what I'm trying to show you is that with the setter and input setup, we can make the circuit memorize whatever our input was at a specific point in time. And this is very valuable for us understanding how a computer can memorize binary digits, which binary digits are, once again, voltage off is a 0 and voltage on is a 1 in what is considered binary. And then we can do operations with those binary digits. Well, I hope you've learned some about how memory in a computer works. I hope it was informative. If you have more questions, I would encourage you to either ask them to me in the comments or to go try and find another YouTuber that talks about this circuit and hopefully does a little better than I have. Well, thanks for watching. Hope to see you next time. Bye.